Okay, I think we're going to get started here. Maybe some others will be joining us along, either online or in person here. I am Jeff Barr, manager of telescope and site for Rubin Construction, and also one of the leading members of the working group that's implementing the computerized maintenance management system for us. Looks like pretty good attendance here, so I'm going to move on to my first slide. Here, okay. I wanted to introduce a bit get the minimize. Thank you. I wanted to introduce a bit the overall topic and just give you some introductory remarks, really, from my perspective on this process so far. The company that we've engaged with is Tecnoteca. It's a company in Italy. They have done work worldwide in implementing this kind of system for lots of different kinds of organizations. The product that we're using is called openMAINT. I don't know if everybody's familiar with that, but it's an open sourced software for managing maintenance of all kinds of things, typically buildings, hospitals, who knows what, nuclear power plants, things like that, but not so much telescopes. We've been working with them for about a year. We had a meeting like this last year at the PCW and introduced the topic, and really we were just at the handshake stage at that point with Tecnoteca. And now we've had a year of progress, and we've made progress. I think you're going to see that for sure, but there have been some challenges. The kinds of things that we maintain and the nature of an observatory isn't natural to any form of maintenance management system that we were able to find. Holger is going to tell you a little bit about the selection process, but some of that has been a learning curve on our side and a learning curve on their side as well. And you can see here that the working group these are just we've had other participants coming and going, people in various levels of management of specific systems, but this is kind of the core group that seems to be kind of continuing now. And we need help from everybody, not just the people in this room or people on the committee, but really the people throughout our organization who know about their systems as we go forward. That's what's going to be the key to this success. Also wanted to mention the things that we're essentially doing in parallel now in this development process with Tecnoteca and amongst ourselves, really. We spend a lot of time on it. We meet once a week, every Friday at 7 in the morning. In case you need another meeting in your lives, you're welcome to join us, and we'd be happy to put you on the team. And we're also having now meetings a little bit more frequently, side meetings to generate some products so that we can then have a little more productive discussion every Friday. So that's going very well. One of the things that Ian has been helping us with most recently, and others in our IT department, and also the IT for Tecnoteca, is in connectivity. It wasn't that easy to get the access for them to the mountain, for us to their system, the interface to our JIRA system, because this computerized maintenance management system is supposed to generate tickets within our JIRA system for the Summit regular work program and other kinds of tickets for tracking the progress on tasks. All of that stuff was not easy to do. We still haven't really established all of it, but we have enough now that we've got you're going to see the semblance of a setup here when we go through the demo. Also, a decomposition, breakdown, however you want to describe it, outline of what the observatory is and what parts of it need maintenance is also not a slam dunk. That's the kind of thing we're having to reinvent it a bit. Nothing comes out of SolidWorks or comes out of our WBS that just naturally pull it in and you've got the breakdown of your facility. So I think that has been part of our challenge, and you'll see some of that as work in progress too. Documentation over the years, I'm going to say 11 years of construction of something like that of Rubin Construction. Our vendors have given us a ton of documents, and we've generated our own, and we have repositories and DocuShare and Confluence and lots of other places. And none of that is ready-made for a maintenance management system either. All the kinds of things that we need to be able to pull out of those, owner's manual, part lists, procedural kinds of things, those need to be developed, and we're in the process of doing that, and that is going to be definitely a mutual effort where we have to go back sometimes to vendors, sometimes within our own team. 3D modeling has been a bit of a challenge also. Most of our models, a lot, at least on the telescope and site side, are in SolidWorks. And that does not neatly convert to modeling for that's accessible. We'd like to be able to have the technician in the field be able to go out, pull open a part that they're looking at, some drive that has a gear in it or some kind of a bearing or something, and the parts on that, and be able to identify what it is. Is there one in stock? Am I looking at the right thing? Those kinds of field assist devices within it. Modeling is a big part of that, and so we really want that to work. And the openMAINT system incorporates models, but not of a format that we've been able. You'll see a little bit of that too. Also, getting all that information into the system has been a challenge. They have a kind of a natural way that they ordinarily take information, but a lot of times it's information about a building, not so much about a telescope or a coating plant or something like that. And so the conversion of what we have and how to get that in a logical set of designators and descriptors into openMAINT has also been a challenge, and I think you'll see that. We've just begun. Mario Rivera and others have been helping us with the technician interface and testing. That's what's coming in the very near future in the field on Pachon, and we'll see more and more of that. And as we get informed and they take this tool out and begin to use it in the field with whichever device they're using, we'll learn, they'll learn, and that's going to feed back in. The things we have yet to start, clearly we'd like to be able to use this, and it has a natural way of incorporating warehouse control or bench stock spares, what's available, and making sure that we keep the right parts. And if you use something, then it's automatically recorded and you replace it. That kind of interface is natural to openMAINT. We need to take advantage of that. Have not even begun to open that door yet. Also, as an aid to our EFD engineering facilities database for troubleshooting and for diagnostics and things like that. That's another feature yet to be utilized. And training. We have not done any training. Those of us on the committee have been learning by, right. Yeah, but gradually we're all going to get familiar with this system. And they do have a very formalized training program, an extensive set of trainings for various levels of usership, administrator, those kinds of things. And we'll be taking advantage of that in the near future too. And so not everyone will need to be trained on that. Somebody that just wants to do a ticket in the system probably doesn't need to be trained. Any technician that uses it will, and those of us that administer the system will certainly have training to come. I mentioned the modeling, and you can see some pictures here. These are models that were converted by Bill Shaning from SolidWorks to a model format called IFC. I'm not even sure what it stands for, but it's the normal kind of 3D model that openMAINT uses very readily. And we have some success with that and not as much as we've wanted so far. We're starting with, you can see this is a small telescope, our auxiliary telescope, or Auxtel as we call it. And it has a lot of the same kinds of things. You can see the list on the left that are normal to the building that we have, the big telescope that we have and need to maintain. And so that is a logical place to start. We can start small, and it actually represents a lot of the same kinds of challenges and types of parts and pieces that we're going to have in the main building or in the main telescope as well. So you can see some examples there. The idea is that a technician would go out in the field and they would have a big model. They would be able to zoom into an area and then on a part, and then open up, find out something, a part of a part, and be able to tell what that is. And so you can see we're already beginning to develop the tools to be able to get to that level. And I know you can all imagine that that's a useful thing to be able to do. Sometimes they're very familiar. It could be somebody that's not familiar at all. And so that this feels like something that we really need. And the challenge, we're going to have to overcome somehow that conversion of files. So we're doing okay with that now. You're going to see some more when Alberto Pitolo comes online. I think we can introduce ourselves one at a time as we all come on here, those of us that are leading this effort. But Alberto will be showing you a demonstration of where we are right now in the system and walking you through. And he's got another model that he'll be bringing in from the camera system. So that'll broaden the conversation a bit. Last thing I want to say before turning this over to those that are going to show you something a little more real and not just remarks. I just wanted to give you kind of a few things that are advisory and also hopefully a little inspirational. Much of what we're already having to pull into this system, I started out life on Rubin as the architect for the building, and that's been built for, I don't even want to think how long now, something like 6 or 8 years probably since we've really been working on the building. We've had things to maintain for a long time is the point. The same way Oxtel has been turned over. The coating plant was delivered by the vendor. All of the parts and pieces inside the building, all of our HVAC system and everything else are already there and already need maintenance. And so those things are high priorities, but also something that gives us the opportunity to bring real stuff in now that is getting real periodic and preventative maintenance. The Noir Lab group is well represented here today. They can introduce themselves as they maybe ask questions as we move forward. But they now have also selected Tecnoteca and openMAINT as their system for computerized maintenance. Clearly their observatories have been in operation a lot longer than we're not in operation, but theirs have been in operation for a long time. So they're going to start at a different level and maybe have different challenges. And we hope to be able to learn from each other as we go forward and have a really good synergistic development going on. Oh, let me go backwards one. Mean to quite hit that yet. Oh, can you go back one? I just refreshed my memory on the other things I wanted to say. Yeah, there we go. So we need to have everyone who is something of a system or a subject matter expert in their areas, and everyone who has a stake in this, to begin to think about how your systems and components can be maintained and what sorts of procedures and what sorts of documents need to be ingested into the system for your areas. We're going to have to work through that systematically. Once this thing is up and running system, that's only going to be a fraction of the work to get to make it really a usable tool. So again, we don't need just us. We need all of the others out there that will be helping us to do that. And then, of course, the obvious thing is that we don't want this to be just another layer technological bureaucracy on top of what the technicians need to do. We want it to be a useful tool that saves them time and keeps our equipment in better shape so that it doesn't fail so often. And I know that's everybody's goal. It seems like a really obvious thing to say, but a lot of times when you develop a tool like this, and there was already other tools out there, we already have a JIRA system. We already have a DocuShare for our documents. The technicians already know how to use SolidWorks to open a model in the field if they need it. So we need to figure out how to make this tool, put those things together in a really logical way that facilitates our maintenance rather than complicates it. Okay, and with that, I am turning over to Holger Drass, who represents systems engineering and also has been a lead ever since we went into the selection process, which is what he's going to talk about.
Thank you. Can I take this from you? Yeah. Yes, so hello, my name is Holger Drass. Many of you saw me yesterday at a different talk. So today we are changing a bit of topic. Thanks for the introduction. And this is actually something we have done about a year and a half ago, and I started to present it last year. I also have shown it to our colleagues from Noir Lab. And I would like to give here a really quick summary on this part. It's actually a bit of a piece of work on the systems engineering side. And it's something that was a very nice, a very valuable experience for me. And I think something that we should cultivate for other situations. So I come off here. So we have set up this process here to actually select a system, in this case a CMMS. And we started off with our motivation. We were building a working group. Jeff already showed us who was a member of it. Then we set up a number of use cases. And then it goes up here. We derived our requirements that became an official document. We did a complete trade-off analysis. That is actually quite a bit of work. And after that, we entered into a candidate selection. And what is another, each of these dots actually is describing a process. What was our motivation? Everybody wants to have a great observatory. We will have one, and we want to have it to last forever. So that will not happening by itself. And this was foreseen. People wrote the requirements on this. I will not go into further detail, but it starts off very abstract. So when we were thinking on how to realize this, for this working group, here as a member at that time, it was expanded over time, many more entered there, was doing the first development of this process. Particularly Austin, who is here, he initiated the idea for this. We looked at our observatory, we looked what our needs, we derived use cases, common ones for preventive maintenance and predictive maintenance, and we took 40 early design decisions. Afterwards, looking back, what's a very good idea of all what we had in between, and it was really useful to early on say some certain things we want and others we don't want. We made 10 categories out of it. And the 10 categories, actually, you can read them here. They became the 10 chapters of our requirement documents, because each of these chapters is what we actually believe needs to be fulfilled in a certain way. And we gave major importance to this part up here, and pricing and effort. It's on the list, but it was not a major criterion. Up to the very, very far end. So this one was never driving our decision and on our selection on the system. Yes. So then we went into the trade-off analysis. We gave weights to our categories. We asked the question, how important is every of these criteria to any one of the people in the group? You can imagine 10 categories, 10 people. Then you start to cross-match all of this. It gets a little bit of a process. And we ended up with what we liked most, what we wanted to have, a wish list. And we asked a number of people to provide us what they can offer in their commercial systems. And you see here again, it's quite a process. We had a general selection. We made the best of. We did the trade-off analysis over there. We got community feedback. We did demos, and until the point where we had a decision, and we did a review on all of this with our working group. So that's what our decision is. Everybody knows it. Yes, as at this time, we were just about here with the installation of the system. Today, we have a good part of configuration and testing already going on. The requirements verification is something that we keep to the very late end. Okay, so as I promised, it would be very short. Questions whenever you want. I have another presentation on this. I'm happy to share it, giving any details that you want. If you want to do this kind of process, yeah, sure, we are into it. And now it's about the demonstration of the preventive and predictive maintenance. Alberto and Matthew are going to do it. Do you want to start, Matthew, or?
Actually, I think Alberto's going to start.
Okay. So Alberto, can you hear us? Now the voice.
Yes, of course. Can you hear me?
Yes. Hello, Alberto from Italy.
Hello.
Yeah. So,
Hello,
do you like to
hello,
take
everybody.
over the screen?
Yes,
Can you stop
sure.
sharing here?
Okay.
You should be able to screen share now.
Yeah, now yes, because before no, but now I should. Can you see my screen now?
Yes, coming up. It's good.
You're good.
Yep. So, hello everybody. I'm Alberto Pittolo from Tecnoteca. As they've introduced me, I don't want to spend many words on me, but on the applications. I'm the project leader of openMAINT, and following as the project manager also the project with our LSSD Rubin Observatory. So we are working together to configure our standard application for the purposes and the goals of your, let's say, target. I would like to have a quick overview of the system before turn over to Matthew that gives you further information. So basically, I am already logged on your system. Here you see exactly your application. So I am connecting to you on your premises. So sorry if it's a bit slow, but here from Italy, I'm a bit far away, so it will take longer than for you. As you can see, I'm already logged as a super user, so as an administrator, but the same applies to the standard users with their corresponding grants and permissions. So everybody can see only the configured informations according to the privacy and grants configuration. Basically, we have so far configured these modules that means facility and assets. So basically where the things are placed, the main complexes, buildings, and locations. So here you can see, for example, the structure of the area of the summit or the observatory where it is placed in terms of, as I said, complex, buildings, floors, area, rooms. And then you have the assets. Another model is basic archives. That means all the internal, external, customer or client personnel, so employees or operators, as well as teams or companies. Then we have the maintenance management, and I will discuss this also, Matthew, to take care of corrective maintenance, so the breakdown processes, and also preventive maintenance, so the scheduled one, and then further configurations. So basically, going a little bit in depth of locations, here you can see, for example, the complexes that, say, typically describe things that are buildings that are grouped together, and we have the Mentals complex, the base complex, the village, calibration hill complex, warehouse, and so on and so forth. And for each of those, you can, of course, register a bunch of data, like basic informations such as the address, but also specific informations as conditions, criticality, total of buildings that can be computed also automatically, and so on and so forth. The same applies for any entity of the system. And of course, for example, you can put, for example, here, let's take one that has some coordinates. So you can put, for example, the place where the asset is located. And this way, for example, let's take this one. If you, instead of a, let's say, grid punctual information, you open the map, you can also see where the thing is placed in the world. Now it's really zoomed in, but I can zoom a little bit out, and to see, you can see here where the basic stuff are placed. So you can have from not only the building location, but if you want, register also the asset location. So if you go in depth, here you can load maybe practically where the things are placed. Jumping back to the grid view, beside this location structure, we have maybe a more interesting for you asset organization, where we have started, as Holger has said, to categorize all the assets. Here you have a general, let's say, asset recap, where it lists you all the assets that you have a subtype. So we have shutters, telescopes, gauges, fans, and so on and so forth, with all their codes and names and properties, and also the other asset to which they are related as a part of so far. So you have a direct connection to the, let's say, main parent. With this information, we are capable to build a hierarchical structure, as you can see here, that is the asset structure. And for example, I can see here the main buildings defined in the system, and that according to relation of parent son or parent children, you can, for example, see that I have the Auxtels building, and that contains, of course, a lot of assets that you can see here. Let me enlarge a bit. So you have the vacuum gauge, the Auxtel itself, because have maybe subject to maintenance and so on. And the Auxtel itself can contain, as you can see, all these assets like a motor, a dome, and so on and so forth. And you can, if you want, of course, go even farther, saying that maybe the motor consists of maybe pumps, pistons, screws. You can go in depth as many levels as you want. This is a hierarchical view, and you can, of course, select one of those and see the specific properties of each one of that components. And it's a way of see the things. But you have another complementary way to navigate the system. Is not hierarchical, but is more by category or by family, if you prefer. So here, by categories, you have, let's say, all the asset categories, and you can see maybe I want to focus only on chiller. And so if I select chiller, I see here only the chillers, or maybe I go under, let's say, where is it? Motor here, and I can see only the motors. As you've seen before, you don't have only a map, bidimensional map visualization, but we have also a 3D viewer. And in this case, for example, you have a motor here, you can open it, and if you have the details of the motor, you can show it, and also for the operator or the guy that has to maintain the object, you have all its basic components, and it's a more practical, let's say, a quick way to understand it. And if I click on any element, it will tell me, okay, it will highlight it, and it will also select here, and I can see what part of the component it is. So maybe any place can be has a azimuth motor, flex plate can be selected, and it will give me the main informations concerning to that piece of this is the roller retention. But I can do also the other way. So in this way, I select from the model. So I want to know informations about this thing, and but I can also go here that is more structural representation of the model, and I can select it, and it will bring me to that piece of component. So let me enlarge it, maybe it's a bit clearer. So it's a bi-directional selection. And so here, as I said, you can navigate as a 3D viewer that can be really, really helpful in the processes of maintenance activities. Beyond that, let me show you another thing. Here you have basic archives, and as I said, it works as for the location. So you have the archive for the companies that are involved in your organization, and also the employees in terms of internal, external. You can register anyone you want. For example, here it's Holger, Drass, and other guys. I don't want to take so much on this, but I would like to go on the maintenance management, that is the crucial point for the application. And as I said, you have mainly two processes, two flows. One is the corrective maintenance here that allows you to have a breakdown management of the activities. For example, if something breaks or is damaged, I can open and start a corrective maintenance. Then Matthew will show you that we have set up an interaction from openMAINT, and when you start a maintenance, also that maintenance will be will open a ticket on Jira automatically, and we can communicate different properties, different data, and also in both ways. So from openMAINT to Jira, but also from Jira to openMAINT. And so this will synchronize, let's say, the activities within openMAINT and Jira. You can specify requester priorities, service levels agreements, so times of execution, because maybe you want it to be quick, because otherwise you cannot go ahead with the research of the science activities. And you specify a site where there is the breakdown or the damage. You can specify the location, or also the CI, let's say the configuration item, so the specific asset that has problems, and so other many data that maybe later Matthew will show you. Concerning the preventive maintenance instead, you have scheduled activities, and here you can see that are the main process ongoing processes. So this is an execution, the others are in acceptance, but there is a planner, so you have an overview of all the planned activities that are set up from now going on in the future. So you can see here, if I enlarge a bit, so let me squeeze the timeline. You can see that you have approximately one a month. You can see these lines are the occurrences that span, if I zoom in, span exactly the amount of time that is configured, for example, for this activity shutter change out. It will take me, for example, 6 hours. So this box will cover that 6 hours, and I can see what is planned for the future. And maybe if I see that two activities overlap, I can say, okay, these two teams and that guys cannot do both these activities the same day, so I can select one and move it forward or backward, so I can replan the automatical schedule according to what I have configured into the system punctually by moving maybe some specific events, because they overlap each other. So the proposed schedule is, of course, according to what I have configured in the system, maybe 1 week, once a week, once a year, and so on and so forth. But I can change if I want. Of course, beyond this, I can start preventive maintenance at once if I need it. And I can also have not only a planner, but maybe a more useful, it's upon you, calendar here that tells you also, rating of the color, the status of the processes, of the maintenances that are going on, and when they are planned. Of course, in a month view, in a week view, or maybe as a list like a diary. And I can filter it, of course, by building, so by where I have to do this, and also by team, maybe because I want to see the working load of the team and to see how it is going on. So I can filter this view. Beyond this, I have also the configuration of the consumables in terms of spare parts. So I know how many pieces I have and where they are placed and they are stored, so that I can use them within the maintenance processes, both corrective or preventive. So I can say, okay, I've used this spare part, I can use this consumable, or 3, 4 of these, and automatically they will be unloaded or set as user from where they have been taken. For example, here there is I will show you a quick report that gives you the overview of what is inside. For example, it tells me that I have a camera screen view slot that has been loaded in this location, that date. I have 46 pieces, but maybe I have an unload for that optical shift of one part, because maybe it has been, as I said, used by the AUX telescope, and probably it has been set into used into a maintenance process during an activity. So this gives gives me an overview maybe of how many pieces I have in total for each component, and all the movements that so usages or loads or put back in the warehouse that I've had during time, and I can filter it according to the location. So to decide, maybe I want to focus only on the movements that are related to the aux telescope or the ones that are based on the main telescope. So I can filter that report accordingly. I don't know. I can say more, but I don't want to take much more time for the other things that have to be said. So Matthew, if you want, I can give you the word to maybe show something concerning the preventive and corrective maintenance. I don't know. Tell me. For me,
Yep, I'm ready.
it's the same. Okay. Okay. Thank you to everybody. And of course, if there is some question, please feel free to ask.
Yes. So I will pause for a second for questions. Just introduce myself. I'm Matthew Ramori. Matt's fine too. I was actually on LSST proper, building the science rafts, so I'm very familiar with a lot of the hardware, which has helped a lot, and have since moved over to systems engineering. So with that, before I continue, are there any general questions right now? Okay, in that case, what I will do is if you could stop sharing, Alberto.
Yes, sure.
Thank you.
The screen is yours. I cannot hear
Oh,
anything. So if there are questions, please can you relay it for me or relay them for me?
so let me take a step back because we've
Yep.
said a lot. The main goals that we have really for CMMS really, and please chime in as necessary to the team. We want to make sure we capture the and schedule, optimize this preventive maintenance. We want to make sure we capture and understand the corrective maintenance over time. And then third, provide data so we can add predictive maintenance as well. So all of that leads into, it's very important that the team understands what and how they want to implement their decomposition and maintenance procedures in here. If you don't have an asset, at least at this time. Holger is going to talk about the data model, and I'll explain more how we went through a process of ingesting what we have here currently. But if we don't have enough information, we won't get the data that we need for, let's say, predictive maintenance. So it is critical from that aspect. The other thing I'll say is a lot of these, you can think of assets, at least right now in the current data model, as a serial number. So they are not a position. The other thing that's important is assets are strongly tied to their categories. We have not really utilized the categories to add limitations and expectations, as not just at the asset level, but the maintenance part too. So when we have a category, we can say, this is an electrical part. We know it's AC/DC. We can make that property or attribute on the category. So let me just step through a little bit of what we've ingested so far. You see here we have the site structure that Alberto walked through and called locations, sites, complexes, buildings, floors, areas. We are trying to think ahead towards what Noir Lab wants to implement as well. So at least right now, we made a very basic taxonomy of prepending RU. So we do want to think about that in the future so that when we do the ingest, we don't have to go back and change things. From there, let's say we want to look at the main tel. We currently we have it split up into two different building sides, the service side and the telescope enclosure. There's other portions as well that are treated as buildings, but sometimes they're also treated as areas. Let's see if that shows up. There we go. So right now we have these different areas associated. For buildings are very obvious. Floors we treat as single floors currently, And rooms we treat as discrete, something within walls. Areas can cross those boundaries a little easier. So now to the assets. If I open up Oxtel, oh, I already have it open. As Alberto showed you, we have the building itself. We have various assets. All these sub assets, I'll call them for a second, are associated directly to the building. But if you open it up, you will see all the assets that are associated directly to that parent point. So what we've done is we've created a few assets at a basic level just to exercise the system, understand what the connections we have are, and that way we can move forward by, for example, knowing the information we have to transfer between CMMS and JIRA. So I'll show you one example of corrective maintenance, which is tied to JIRA. So we want to start a corrective maintenance activity. In this case, we're going to say test again. And in this case, I know what I'm looking for. So I will go to the site of Oxtel building. I will say the type is breakdown. I'll put a priority on it. Requester, Holger has a lot of open tickets. And then since I know what I'm looking for, I can just go, actually, I could just say shutter, and it will pare down what I need. Part of that configuration aspect where we want to explore is this would already shorten things down. So if the activity that we're picking is already associated to a certain category, that's all that you would see here. But in this case, we're going to say shutter and hit execute. So at this point, I can close the card if I wanted to. Oh, no, I can't. So now that we have the maintenance actually existing, we can say we're going to assign to a team. And what is the required thing that I need? Move down further.
Those bordered in, yes, in red.
CI. Sorry. Oh, that's where. Okay. So in this case, we want the optical team to do this. Looks like categories required.
Yes, to, let's say, categorize the ticket according to have like also statistics for the failures and so on and so forth.
So we know it's a shutter.
Yes, you can add it at once if you want. Just press the lens.
Doesn't seem to be coming up.
Yeah, yes, just press just press the lens on the category. Yeah, no.
Thank you.
Yeah, that one. Yeah, and that one just to just one other category because you don't have configured it.
That's
so
right.
Just put the name of category, whatever you want.
So now we're associating the category to this new activity.
But this will be stored into the system, so in the future you will still have it.
Correct.
Yeah. And also a subcategory you can have maybe shutter component. This helps in backward learning to know how many of these types of breakdowns I have, for example, in mechanical, electrical, so something like that. Select the category ever.
Yeah, should I get one?
Just
there we go. That's what I'm looking for. Oxtel shutter. Save. Save. Now execute is now available. I hit execute. This moves into a new phase. Which you can see we're in the execution phase now. At this point, we can look in JIRA and we will see that the maintenance activity has been transferred over. We still need to define what information we want to provide, what information we want to provide in the reverse direction, as well as what users will interface with what system. So hypothetically, if a technician goes, okay, I'm working on this, they click here, it goes into CMMS, and we could have a link to a procedure that would be captured that way. I think you got the point. I'll just skip that part. Okay, so then the other type of maintenance that's in the default configuration for openMAINT is preventive maintenance. So in this case, we chose two different activities to try to play with the idea that there's two different types of assets that can work within these maintenance schedules. So one is a shutter cleaning, which would be the cleaning of a camera shutter, either Oxtel or Maintel, or sorry, LSST cam. And then over time, we would want to change the LSST cam shutter changeout. I apologize for the name, but at that point, we want that scheduled around how many cycles it's using. That type of configuration we know will be implemented in the future. We're not there yet. We need to understand how to interface with hypothetically the EFD or something to do that. So if we were to start a preventive maintenance activity, we want an action of starting an activity. Right. We want to do, let's do the Oxtel shutter cleaning. The execution date will be tomorrow. We can execute directly from here. And at this point, we are in the acceptance phase. So we can basically work release at that extent. So let's start execution, execute again. So somebody would perform the activity. Let's say it ends that day. Outcome shutter inspection looks good. And we can save what's required. Oh, and then we change it to conclude the activity. The outcome was positive. This is an additional information task, so it's not technically required at this point, but we can configure that as needed. Execute. And that will conclude that preventive maintenance activity. So
you don't see it because it's on the completed one. You have to select, on that the active processes on the left-hand side. Yes, you go on completed or all.
Just do all.
And here you can see the completed one.
I think that's about it. If hypothetically right now, like I said, it's not set up to be smart yet, but if we were to do the other activity of changing out the shutter on the camera, you would go into the asset, you change the location, so at least it's tracked that way. I could show you that, but I think in the name of time, we can continue to the next part. Unless there's any questions on what I've shown you, then we can move to the Holger is going to discuss sort of how the default configuration is from a database standpoint, and then that way we can kind of lead into how we actually did the ingest, because without that information, this just looks like a spreadsheet. So I will turn it over. Oh, okay, sure.
Got a question. I'm Mark Greshka from the Safety Council. It's a very impressive system. I want to say that. Is there an opportunity and a plan to incorporate hazard information when one of these is brought up? For instance, if a task is getting involved in things that require lockout or tag out, confined space, special permitting like hot work, that kind of stuff. Is there a way of either being able to put it in manually, or is it tied into the existing database from another platform?
I think we can do either, honestly. I don't know the database that information is stored in currently, but openMAINT is extremely configurable. So to tie into that, some REST API or something, I'm sure that's achievable. That's where we can describe the information that we need from Tecnoteca, and they can develop that for us in this early stage. And then to address the other scenario, yes, right now, what you just saw was just a one-step activity. If we wanted the fidelity of you need to pause or have a hold point, or you need to make sure your hot work permit is active and approved, we can configure that in the activity itself.
Yeah, the only thing I would add to that is that the key to that will be the maintenance or the documentation, the kinds of job hazard analysis and the material safety data sheets, those kinds of things should be part of the complement of documents that come up automatically for a technician in the field. I think that feels to me like the key to that and answer that question.
Yes.
It's not necessarily there's not a hazard that I know of anyway, a particular hazard category that they would normally fill in for anything on a as part of openMAINT, but it certainly would be part of our documentation for the job.
Absolutely. We will definitely take this with Alberto and see what else we can do to extend the software, though.
Yes, I can confirm that for sure it can be done, and then it has been done for some of other customers that has this similar needs. So yes, we can just discuss the details of that and bring them into the system without problems.
Thanks, Alberto.
Yeah, I would just add that, part of when we were doing the selection, as Jeff kind of mentioned, we already have a lot of documentation from like vendors and stuff like that as like required maintenance procedures and such. So one of the things that we were looking at the tool is, for one, making sure that we could just link to the procedure. But this tool also does have the ability to actually compose like step-by-step procedures within it. But that would obviously require a lot of work to take maintenance procedures that we already have and add them in there. But it is very customizable. So we could add like a field, like flag, if something's like a significant, safety risk involved in the procedure or something like that. But all of the procedures that we link to, that someone would actually pull up or print out or however they want to do it, those procedures would have all of your standard job safety analysis and all that.
Mhm.
Right.
Excuse me, this is Eduardo.
Hey,
Where-
Eduardo.
Hey, where we can see the final report for each maintenance?
I'm sorry, can you repeat that?
Where we can see the final report for each maintenance?
Oh,
We
so
have
like a summary of what happened?
we have
Correct.
many reports that you can see. For example, the first one on the left-hand side, activity report, the first one gives you the report, and you can just select here for one of that. And you can have here, probably you can have the main details and when they have been performed. And also, for example, here, the checklist that have been done and by who and when. And if you have used some spare parts, this will give you also the list of things that you have used. And of course, at the bottom, you can see now that there's, if you go down, yes, there will be performance and customer, but if you load the signatures or teams and you configure it, you can also have signatures there. So have the automatically signed report that is not only visible here, but if you go on the process, there also email has been sent with this report in attachment. So it has not been shown during the demo, but there will be a lot of emails that notify the performer or the team or the administration that please consider that there is being a preventive maintenance planned for that week, or activity has been completed. This is the report. And you can see it if you go, Matthew, on the preventive maintenance and you select all processes from the yes, the top, and you open, yes, that one, the completed one, and you go on the email tab, you can see that there's been automatically generated 2 emails. For example, the first one that you see here, if you open, has been sent to the maintenance office in this case, but you can configure if you open from the right hand side with the bottom of the arrow that is going out of the box. Yes, that one. You can see here there has been some, this is a template, you can modify it, and the main properties of the maintenance, so the basic informations, and you can also load here the report automatically so that it will be sent to you.
Great. Thank you very much. Gracias.
No worries.
I am. Can you hear me in the microphone? All right. I'm Kevin McLaughlin. I just recently joined the NORLAB Systems Engineering and Project Management team, and have just a couple of quick questions. Can you create, when you have a corrective maintenance issue, can you create an issue in Jira, or do you have to create it in CMMS? Is that where the workflow starts?
It would, the way we have it configured right now, it would start in CMMS. We have not talked about the idea of starting in Jira, but we can look into that.
I don't know what the workflows are, so excuse me if I ask a
No, that's okay.
basic question.
Yeah, I was going to emphasize that. A lot of this, we wanted to at least provide a demo to show what we have, what we've thought about using the default configurations. From there, absolutely, we should customize not just the database, but the workflows themselves. So we are looking for any and all feedback.
That's great. I have just a couple more quick things. One thing I was interested when you were setting up your example report, you created an issue against a component. Excuse me for using some old parlance.
No, it's okay.
Component, and then you assigned it to Holger. But someone who's creating an issue may or may not know who to assign it to. So I wonder if it might be useful to have a step that I'm used to using, where you have a default person that something is assigned to, and they have a role of screening that report, and they can then assign it to the correct person because they know they're more familiar with that component perhaps than the person who's creating the issue.
It would be pretty much like this. So
Okay.
you assign the head of a department there, and it would go there, and this person assigns it. So how we have split it up, we have the work management system apart from the CMMS. Not necessarily like this, can do it in here, but since we have an ecosystem that was already existing, where we had a work management system, we are saying explicitly we don't want to do this thing. So it always starts off, at least at the moment, with a generic person close to the field, let's say. And then we are in our world of Jira, and where work management is done and scheduling is actually done. Yes. And then it ends up on the summit calendar from where it is executed.
That sounds good. And the last thing I was interested if you'll be able to talk a little bit more about the reports that can be generated out of this tool.
We have, yeah, it's actually, we have full flexibility on all fields that we want to have, and we have full flexibility on each content of what we want to see over there. We have also a flexibility of the topics. Let's say we want to have over a certain time for a certain asset, we can generate this. We can have it as a template in there. Then we can have here a card where we select component, time span, press a button, and then it turns out what you want. Yes, so we get all of this. We can also say, for example, position. Let's say we have our main mirror. It has over 100 actuators. We want to have a certain position. Whatever happened to this position, we can also do this. And it shows all the parts that have ever been pointed to this position and their state of health and things like this. Yeah.
Thank you.
Yes, please.
Please.
First one is if I want to arrive to a certain part, is it possible to arrive to that part through multiple paths? So
Yes.
give you an example. Can I get, for example, like dome, drive system, motor?
Absolutely.
Electrical,
Yes.
Yes.
motors, dome drive?
It's entirely pick your own adventure. Yes.
Okay.
So you can have a search field. You have a word in mind that's associated to it.
Yeah.
You will get everything that relates to it out of it. you can go here through the tree structure and select it, or you can come from the 3D model. You roughly know where it might be located. You turn around, you pick yourself through the system, you click in it, and it will again bring you there to the asset and to the related activities. So this is, you can also come from an activity if you want to. I would be more likely, not so likely at the beginning, yes. But once the ticket is generated, somebody says, okay, but where do I have to go? And we give you all the information on where to go, what to bring, and things like this.
And my second question, you mentioned that your third step is to implement predictive maintenance. Does this software has the capability to pull information from your telemetry database and start create trends?
Bring me online here. I bring you to the backup.
So
If you don't-
ultimately, yes. What we do need to do is understand those interfaces so it can be configured. But our kind of prime example, and let me put out there that we are collecting these examples to exercise the system so we know what we want to configure correctly. And this is a very good one was for the LSST cam. We know we have X amount of cycles before we change out. We say we want 9,000. We want to know beforehand, so 8,000. And then that way it will read the EFD, it will read a different example, a thermocouple somewhere, an hour rolling time of runtime that can be configured. I'm gonna actually stop sharing anyway because Holger will show you a little more in the presentation before I jump back in for how we actually ingested this information.
Yeah. Thanks. Okay. So I will jump to answer your question here to our backup slide. It's a little bit, I take a second and try to make it a little bit bigger for you. So over here, we have the central part of the CMD system. And we have down here the database that is related actually to the CMMS system. And I will talk about a little bit more on this one. But what you see out of here is that we have a complete infrastructure of advanced programming interfaces that can be used to bring information into the openMAINT. Okay, so I take one step back because this one is not clear. If you have not seen this before, it says CMD build here. So CMD build is the overall system where openMAINT is an it's a specification of a, yes. So there are two different specifications. Our one is for asset management. The other one is used for governance as management. And so this one you can exchange in your mind for the openMAINT here for us. And here we have then the import parts where we have operators and administrators. There's a self-service portal that we still have to explore in detail, and we have activated the mobile app. So from your telephone, basically here in the room, you could launch a request for a maintenance activity. On the other side is using the same mechanism. It is that we can have tools that are sending messages here, or what's called here the Internet of Things. That would be, for example, our environment awareness system that could enter up here and could directly communicate to launch an activity, for example. And our engineering facility database could be one point, ending point here, and we read from it directly, and then we could start things. And that is basically brings you to an unlimited possibility of things that you can connect here. As long as you have this very widely distributed standard, you can connect whatever you like. I think that's important for the for NOAALab and all the other telescopes that here that they are inheriting standards that are widely used.
And then I'll just add one more thing, more directly to predictive maintenance. This is where that fidelity is really crucial. Do we know there are 3 positions of thermocouples, and one of those positions keeps dying 6 months earlier than its expected lifetime. If we don't have that information in the system, if we don't have the fidelity of the decomposition enough, we can't really do it that way. So there's definitely going to be a balance between the technical teams of how do I find the right part? How do I not ingest every single nut and bolt? But also on the management side of oversight of where do we want the information so we can utilize predictive maintenance specifically. And that brings us to the data model.
Yeah, let's take a quick look here. That's something that we have to get into it, set our minds for it, and we might not have been perfectly prepared for this in the beginning. So this is what I would like to bring it up. It's a software and IT aspect of it. So this one uses an object relational database. And this kind of database needs a certain kind of data model that we have to implement. And here I have an example that was provided in their documentation. And what we actually have to do is work on developing our own model here. Yeah, an entity relationship model. It's so we have to do this, or they suggest that we do this with a small set. What would be our Oxtel? That would be something we have to find probably for each observatory, something, or maybe we can find a common model that we can use for all observatories in all telescopes. And that means that we have to talk about things like what types of items we want to have, classes in this case. We have to discuss more in detail what are our assets. Yes, assets, they are called here configuration items. IT specialists probably know this from their world. We translate it into assets. This is really one-to-one at the moment, at least for us. But you will come over this CI terminology again and again. So I want to upload here for everybody this that we have to translate in our minds. Okay. Sorry. One more aspect. I don't go too much into detail here. Yeah, yeah, but we should then go in what types of items we have, what attributes they have, how they relate to each other, and things like this. We should make ourselves minds up. Do we want to have super classes? How many do we want to have? How do we inherit from different classes? We have, as you will show this now, they gave us a really nice template, but they also suggest that we make up our minds early on this specific part because it will be difficult to change it later on. So maybe we decide we don't have so much to do and we only use the normal classes and then we maybe get rid of it. Yes, we should just make up our minds at some moment. Yeah. And then at the end, we end up what you have seen here, the administration module will be filled with the things that we have designed over here. And then the management module is where the user actually is, yes. Again, another wording, management module is a user module actually. Administrator module is the one where the system administrators are working. Okay. So, and I will leave it here as the slides come to you. And we can talk about this later in detail. Maybe Andy can also shine in here. Yeah, so we can look more on aspects of this part. I stop sharing and you can take the last part here.
So we wanted to make sure to preface what I'll show you now, how we got to where we are today. Alberto and Tecnoteca provided us a fairly rudimentary, based on their default configuration, Google Sheet that I'll kind of step through relatively quickly. But so how this process worked is really critical. And we've at least done these locations, which you can see, site, complex, building, floor, area. We fill in the required details and they will ingest it for us. There's a lot of little things to this Excel sheet or Google sheet. If it's a star, it's a required thing. We can add all these properties that we want to. We can add new properties if we want to. They're very flexible and accommodating to the properties or to any changes we want to make to not just the data model, but the entities themselves. Jeff, did you want to chime in? Oh, yeah, okay. So like I said, buildings are obvious. Complexes are sets of buildings or potentially just one. And then sites are physically distinct things as well.
Matt, maybe you can blow that up just a little bit.
Oh, yeah, sure. I'm sorry about that.
I can barely see it from where I am.
That's probably a lot better. Okay. So what's another crucial aspect to understand is all these items are independent from each other. So we do want to specify there are certain sites, there are certain complexes. Those complexes are associated to a site, and so on and so forth. So an area could not. It's potentially that an area is not associated to floor. It might only be associated to a building. Our canonical set of information is an asset and a building. As long as you have those two things, at least how it's configured right now, you can initiate a maintenance activity. We're playing around with different ideas. That's why this installation location is here. I don't want to get too far into that because that has to do with the data model very much. And then the list of assets themselves. This is what they've ingested so far. You can assume this description is what people would see in the front end. Just read it like that. And then each one has a category. This was a property that we asked them to implement in the short term, so we understand what's attached to what, because a lot of the people that are helping us through this think of it as a system, a subsystem, components, subcomponents. So this was a way that we can have the communication aspect between the technical teams, us, and Tecnoteca to move us forward. Where is it located, complex building, etc. And then we've had some ideas about other properties that will be useful. Where's a descriptor, where's a manual, etc. To jump ahead, we haven't really played too much with the company, team, employee, but that's coming fairly soon since we're trying to exercise the system soon. And critically, the categories. So we've built categories and subcategories. Each one can have separate and inherited properties. We haven't really worked towards that yet because that's very much a fundamental aspect of the data model. And then finally, the activities. So you'll see here, there's different steps to an Oxtel mirror cleaning. That one's not implemented right now. These are the subsets of assets that get and maintenance applied to it. So you can say there's a subset of all shutters and they all get a cleaning. So all shutters would be associated to this subset. And this is the mapping of those subsets. We need another tab for categories mapped to subsets instead of assets, and then the actual activities themselves. So there's a building, there's a subset, there's an activity, and there's an activity name with all this associated stuff. And then finally, for consistency, Tecnoteca provides a sort of values page, so that way we're not inconsistent, I'll say. And then the only thing I wanted to point out was we've added a separate piece so that we understand where is the information relayed to technicians, engineers, whoever, about physical locations and drawings of parts. At least right now, this is the data model isn't really set up to do that, so we're kind of piggybacking on a property right now. That's all I really wanted to show. I did want to. The process obviously is very iterative, and that's why I wanted to really ask you guys questions or let you ask questions about the process, because that's a very crucial part to this. Yes, please.
Thank you. My name is Michiel van der Hoven, Director of Engineering Services for Noirlab. I have a question about how you configure this, but let me just take a minute, Jeff, if you allow me to give a bit of introduction what we're trying to do at Noirlab. We're here with the whole engineering management team now. Slaume, head of mechanical, Kevin, head of project and systems, and Jorge Parra, the project manager, implementing the CMS across Noirlab. We're not quite implementing it yet, Jeff. We're doing the inventory just like you're doing. So this is all very, very useful. I have a question about how you configured this. You have your assets, and then you have all these different ways of describing it. And then in the database, you can provide all sorts of filters and find what you need. How do you handle the decomposition of components? And I'm asking the question, one of our telescopes, they have a very clearly defined product tree, which breaks down the telescope. It starts at very high level, telescope, the telescope, then you can have the tube, the mount, then it will go into like an azimuth drive, the motor, the tachometer, and it gives that decomposition. Do you have something like that in here? Because this seems like a very long list of all the components you have, but have you defined as well how they relate to each other, how they are broken down? Is that something which is in here? And
So just to repeat the question, it's how is the decomposition from a more system point of view incorporated in here? And the current data model does not really think of things that way. If we were to change the data model and say, we know there's a class called systems and we know there's a class called subsystems, and we figure out the right connections there, yes, we can think of it that way more directly. Right now, that's actually exactly why we included this column here. It was very difficult to speak so abstractly on the technical side. So to move us along into how can we utilize the system and what do we want to change, we took a decomposition and translated it into what is CMMS need. And so that's actually what you're seeing right now. We did start from, it was a fairly high level decomposition, a much more detailed one that depends on how many parts, but it might not be as easy then. It's an aspect we need to explore, we expect to explore.
We have here a little example. You see the number A, 4 zeros and then 1. So that's Oxtel. In the initial ingest asset association, and we gave this number to the compressor of Oxtel. So these now are two married, and they will appear in the tree that you say under each other. It's a part of relationship that is realized by associating numbers. We have now a part that is, let's say, the filter of the compressor. It would get the number A2. A402 on this right column. Then you would have first level, second level, and the third level under the compressor. It would appear the filter that belongs to this particular compressor. So,
hey, Holger, I could add something there. One of the things is we do not have a formal decomposition of the system to the level of detail that we need to populate this system. So one of the things that we're looking into, instead of going and trying to do that by hand, we have our observatory in our 3D model. I've met with John Andrews, who knows, all about SolidWorks and all of that. And we have a company that we already have a contract with, and they specialize in synchronizing data between various modeling tools. So instead of trying to do all that manual work, we have a contract with them, and they're going to create this connection between our SolidWorks model and our SysML engineering model. And there's some challenges with that, just the way that the model is structured, but that would give us a really good starting point. And then we can start, modifying as we need to. And then we'll have that very kind of formal, official decomposition. And then from there, we can easily export that into like an Excel sheet and then ingest it into the CMMS. So that's something that we're still working out how to do that without, a lot of manpower to generate that.
I'll also add one more thing is the categorization. It is definitely not what Tecnoteca is used to. We have, yes, we have basic building things, but we also have a very specific way we think about a telescope. There's a shutter, there's a dome, there's readout electronics, there's compressors, and that categorization was difficult to figure out how to start. And at least now we have a starting point, but part of this exercise was also figuring that out.
So, but do you think that right now you're able to sort of group assets together? I'm thinking about how you assign responsibilities, right? Because I mean, if you have one person looking after all of this, it's not going to work, right?
Correct.
So, do you feel like you can say, okay, this person is responsible for that group of assets, and with this configuration, you can achieve that? Or
We have. So if you look down there, we have separated tabs out there, one for Oxtel, one for Maintel, and we can have as many as we want to have, as long as we decide on a way how to name these things individually. We can have 10 people working in parallel on different aspects, and then we get over there, we do this association one by one, then we have one top level sheet where we say, okay, Auxtel belongs to the main telescope complex. Let's say something like this. Yes. Yes. So we can be very, yeah, and we can even think broader, doing with different telescope, different observatories. And so it's all hierarchically structured that we can do at the moment. The thing on this assignment part, yes, we can work on, that could be a category or an attribute. So then it can be a certain, these things can be of a certain class, as an electric class, for example, and we have somebody who works on the electrical class, or we say, we don't care, they are all parallel to each other, but then we give it an attribute and say it is electrical, and then we know everything that electrical belongs to a certain team. So that's something database specific. Yeah, so data modeling, it's a discipline on our IT colleagues. We might need a moment to get into their way how to think on this, and then we can really do a set up us in a very coherent way between different observatories, different telescopes.
So our stopgap at this point is to utilize some of the defaults features that come from openMAINT. It knows if you tell it something's connected to Oxtel, you can produce a report that says, well, here's your whole hierarchy. If we take that and shove it into the data model, that's probably a way to start. But like Holger and Austin said, we're trying to explore what the right method is before we get to there.
Yep. I hope you're getting the sense that this is a part of this process that we underestimated going in. We thought, well, we have a work breakdown system. We have SysML. We have part trees and models, all those things. We'll just import it. It ain't that easy. It really is. You got to break it down in a very searchable, intuitive, and logical way for maintenance that's different than anything else we developed. And we struggled with it for a while. And the reason we got to where we are with Oxtel is our documentarian, David Cabrera, went and talked to the lead technician for Oxtel, Mario Rivera, and they came up with something that actually made sense for maintenance.
That's what you see right now.
thank you.
Yeah, we're coming to the end, I think, of the hour here, and I don't know if there's any more questions. We can certainly stay a little bit, but maybe we have 5.
Yep, we still have about 5 minutes. And obviously we can talk anytime during PCW or afterward. I know
I had a
that.
question.
Oh yeah, please.
So this is kind of open-ended. I don't want to throw our NORLab colleagues, or catch you off guard, but just, I mean, having seen kind of what was presented here, what are you guys thinking in terms of like commonality for this system across the various observatories? Because one of the things that we've discussed that we would like to avoid is us going through all of this work, creating this data model, coming up with workflows and processes, and then, when you guys get to that point, then go and say, well, we'd really like to have this common across the things, and then we have to go and try and like restructure anything. or everything. I just, if you need time to process, I totally understand, but just if you had any
No,
thoughts.
no, I think it's a good.
Hmm. Yeah, I mean, yeah, that's kind of the same question.
Let me try and give a few comments. The different programs we have, 4-meter class telescope, 8-meter class telescopes, they are all in need of having a tool like this, right? Several of them have tried to build their own tool. Some of them are custom made, some are their spreadsheets. Some folks have tried to configure these. I think none of them really succeeded in getting it done. Jorge, again, who's the project manager, he looked at the statistics, and a lot of these projects fail. I think it's like 70 or 80% of these projects typically fail. So we have a lot of experience of things go wrong, ideas of how we should be optimizing our maintenance, making more effective use of our resources, better spares management, and so on and so on. So about the question about commonality and going back to Jeff's initial comment, like we are implementing it, that's not at all where we are. What Jorge is doing right now is doing an inventory, go and talk to the different observatories. What is you have? What is it you need? What do you think would work? What would not work? And do that assessment. Everybody or a lot of people are very keen of starting to configure it. And they've been asking Jorge, can you give me the tool? I'm gonna fill it in. I have it all here. And we're trying to manage that expectation by saying, no, we have to take it slow and try and understand what we're trying to do. So I would say it's early stages for us as well. Going back to your question, Chuck, about, I mean, creating in WireLab, we're trying to create common standards, right? Let me give an example. We have people, mechanical engineers that use different tools to do mechanical design. Well, we're moving to one standard because if we're serious about collaborating, we need to standardize, right? The same goes here. So when I heard in talking to Holger about this initiative, I thought this was a fantastic opportunity to see whether we can join forces. And this really will help to get a better understanding of what is it we're trying to do, where can we optimize and get data on. I hear it so often, site managers saying, here, I need more people, I need more budget, but where's the data supporting that? Now, this will provide that. Then going to Slauerme's comment about the predictive maintenance, we're looking into as well on how we can connect different engineering databases. I've heard about your EFD, I think it's called. There are similar databases at other observatories, telemetry. You may have heard about VT-SCADA that we're doing. But the idea really is to see how we can connect all these tools together, right? And in order to do that, I think we need to build a critical mass of people with knowledge and with a bit of time, which is all typically the struggle, to pull this off. And that's the reason why we're here and that's why I brought the whole team here to learn about this and get to know the people. Now with Holger, it's been great, and Chile being very close by, to see whether we can move this forward and support each other. Now, I think from NORLab, we can bring a lot of operational experience, of what people have seen, issues they run into. I was very impressed all the work that you guys have been doing about the requirements definition, the vendor selection. A lot of work went into that, and hopefully we can join forces. No? So, exactly. Exactly. We when we heard about this tool, I remember, and this is not only engineering services. John McLean, who's the head of facilities, was involved in that discussion as well. And the typical question we got is, well, but does it serve our needs? It's probably not good enough, or they may have missed something, right? And so we actually went through that exercise where we looked at your requirements document with the engineering management team. And I asked them like, hey, what do you think of this? Is something missing? And they couldn't find anything because, again, you did a very good job. And then we did decide to adopt this tool. And it may not be the best possible tool, but it's a tool and it's an opportunity to standardize. You know? So yes, we have a project that was defined, which presented to the Noir Lab Directorate and was approved. And the idea is to adopt and implement this in engineering services and in facilities. You know?
So do
So
you?
that's why Holger now is going around to different sites in Chile, Gemini, the 4 meters, the facilities group, and this week in Kid Peak as well. Yes,
Well, so that's
yeah.
where.
I get, yeah.
Reasons why we have to call an end to this meeting. Our hardworking project manager for Tecnoteca, it's 9:30 now in Italy. And there's people arriving for our next meeting, but I think this is a great conversation to continue having. And I thank everyone for the participation and the intelligent questions to help us guide our way and also with early stages for Noir Lab.
Thank you, everybody. Thank you, Alberto, for joining so late. And I appreciate all the feedback.
Thank you to you for the invitation. My pleasure. And
Thank you very much, Alberto.
no worries.
Later.
Have a nice workshop. Bye to everybody.
Bye, everybody.
Muchas gracias. Chao, chao.